In this session, we're going to solve more interesting linear inequalities. And again, I call them more interesting because there are more steps involved. Let's recall that solving a linear inequality is almost identical to solving a linear equation. The difference is that the inequality symbol reverses whenever we multiply or divide by a negative number. And to convince you of why that is, let's consider negative 2 is less than 5. This is a true inequality. And I'm going to multiply the whole thing by negative 1 to demonstrate something, and let's face it, you can't stop me. So when I multiply the negative 2 by negative 1, it becomes a positive 2. And I multiply negative 1 by 5, it becomes a negative 5. And an appropriate inequality symbol between 2 and negative 5 is greater than. In other words, the symbol reversed to keep it a true statement. Let's get started. For our first inequality, we have 3x plus 4 is less than 1/3 times the quantity of x minus 2. And I want to clear the fraction. I'm going to note that the least common denominator in this case is 3. I'm also going to note that I have terms 3x, 4, and 1/3 times the quantity of x minus 2 is one term. Since I have 3 terms, I'm going to write 3 3's to multiply each term by the 3, which is the least common denominator. The first term becomes 9x, and then we have plus 12 is less than. 1/3 times 3 becomes 1, and I don't need to write that. I can lose the parentheses entirely and just write x minus 2. I'm going to subtract x from both sides. That'll give us 8x plus 12 is less than negative 2. And when I subtract 12 from both sides, we get 8x is less than negative 14. And finally, when I divide by 8, I first note that I'm dividing by a positive number, so no inequality symbol needs to reverse. I end up with x is less than, I'm going to reduce the negative 14/8, dividing out the 2's. We have negative 7/4. Now there are several ways that we're going to represent the solution to an inequality. One of them is going to be by graphing on a number line. I'm going to label x a 0, negative 7/4, and because we're looking at x is less than negative 7/4, I'm going to use a parenthesis that opens to the left and shade to the left. Interval notation will start with a parenthesis and negative infinity, comma, negative 7/4, again with a parenthesis. And these are the 3 parts of the solution that I would expect for an inequality. There's another way we can represent this, and that is using set builder notation. For set notation, I'm going to start out with the inequality x is less than negative 7/4, and then we're going to wrap the set builder notation around it with a curly brace, an x, a vertical line, and then close the whole thing up with a curly brace. And remember, the way we read this would be the set of all x, the vertical line is such that x is less than negative 7/4. And of course, don't forget to close the barn door. Our next inequality is 7 plus 5 times the quantity of 3x plus 4 is less than or equal to 7 times the quantity of 2x plus 3 plus 4x. I'd like for you to go ahead and pause the video and solve this one on your own. Our first step is to distribute, and you'll notice that I'm crossing my 7. That's so I don't confuse it with the inequality symbol. When I distribute, I get 15x plus 20 on the left-hand side, less than or equal to 14x plus 21 plus 4x. I'm going to collect my like terms on the left-hand side and the right-hand side, just like I would a linear equation. I have 15x plus 27 is less than or equal to 18x plus 21. Now I'm going to subtract 18x from both sides so I can keep my variable expression on the left-hand side. I have negative 3x plus 27 is less than or equal to 21. I'm going to subtract 27 from both sides to get negative 3x is less than or equal to negative 6. And now when I divide, I notice that I'm going to be dividing by a negative 3. And this is important. The negative 3's divide out on the left-hand side, and I have x on one side and 2 on the other. But since I divided by a negative number, the inequality symbol is going to reverse. And I now have x is greater than or equal to 2. We can express this on a number line with a 0 and a 2. A square bracket at 2 opening to the right, shading to the right. The square bracket we use because we have a non-strict inequality. And the interval notation is going to be 2 to infinity with a square bracket at 2 and a parenthesis at the infinity. And then finally, if we want to use set notation, we would write x is greater than or equal to 2, as we have. We'll put the set of x such that, and then close it with a curly brace. I would accept this as your solution. If you wanted to give set notation, you're more than welcome to. Now notice that we ended up having to reverse the inequality because we divided by a negative 3. And what started all that was right here when we subtracted 18x from both sides. I'm going to put a blue star at this step. And if you're a fan of alternate endings, stay tuned at the end of this video. I'll show you how we could have done this without flipping the inequality symbol. But for now, we're going to move on to the next one. Here we have 3z minus 1 over 4 plus 1 was less than or equal to 1/2 times the quantity of 6z plus 5 plus 2. We're going to clear the fractions in this one by multiplying by the least common denominator. Since our denominators are 4 and 2, the least common denominator is going to be 4. I'd like for you to pause the video and attempt this one. Multiplying each term by 4 means that I'm going to have 4 4s, because notice we had 4 terms in our original inequality. When I multiply the first term by 4, it divides out entirely, and I have 3z minus 1. The rest of the multiplication gives me plus 4 is less than or equal to, and then 1/2 of 4 is 2, and 2 becomes a coefficient of the parenthetic term 6z plus 5, and then 2 times 4 is 8. Well, now I have like terms on the left-hand side. I can distribute on the right-hand side. We get 3z plus 3 is less than or equal to 12z plus 10 plus 8. Collecting like terms on the right-hand side now, we have 3z plus 3 is less than or equal to 12z plus 18. Now, last time we kept the variable on the left-hand side. We ended up with a negative coefficient. This time, I'm going to keep the variable on the right-hand side, making sure that the coefficient stays positive. We're positive people, aren't we? On the left-hand side, we are left with just 3, and then we have less than or equal to 9z plus 18. Now I'm going to subtract 18 from both sides. We get negative 15 is less than or equal to 9z. This may feel a little weird, but we'll see how to deal with this in just a moment. Now when I divide by 9, it's a positive 9. And when I reduce, I have negative 5/3 because 3's will divide out in the numerator and denominator, is less than or equal to z. Now we're not used to having the variable on the right-hand side. Let's see what happens on a number line here. Going to label the number line z, put a 0 for orientation, and my negative 5/3. And if 5/3 is less than z, or equal to, but if 5/3 is less than z, then z must be bigger than 5/3. So I'm going to use a square bracket that opens to the right. Now, if I'd rather not see this inequality backwards, then I can flip the whole thing around. I can write the z first, and then the negative 5/3 like I'm used to. And because the inequality symbol was pointing to the negative 5/3, it's still going to point to the negative 5/3. I see I could say this one out loud as z is greater than or equal to negative 5/3. And so our shading on the number line is correct. Well, we're going to finish this off using interval notation. And that means square bracket negative 5/3 to infinity with a parenthesis. And for set builder notation, I'll rewrite the inequality as we have it. Z is greater than or equal to negative 5/3. Wrap set builder notation around it. Since the variable we're looking at is z, we're writing z such that, and then close the barn door. Our next inequality is 8/10 x plus 3 2/10 times the quantity of x plus 4 is greater than 2x plus 12 6/10 plus 3x minus x. First, we're going to collect our like terms on the right-hand side. We'll end up clearing the decimals, but I'd like fewer terms to begin with. So 8/10 x plus 3 2/10 times the quantity of x plus 4 is greater than, now 2x and 3x add up to 5x minus x gives us 4x plus 12 6/10. Now again, we have two terms on the left-hand side and two terms on the right-hand side. And so when I multiply by 10, and I'm going to use parentheses so it doesn't confuse the decimals, I'm going to use 4/10. So we end up with 8x plus, okay, so 10 times 3.2 becomes 32. And that term has gotten the 10, so I'm not going to distribute that into the parentheses. It is greater than 40x plus 126. Now I'll distribute to clear the parentheses. We have 8x plus 32x plus 128 is greater than 40x plus 126. Now, as usual, I'll collect the like terms on the left-hand side. We have 40x plus 128 is greater than 40x plus 126. This is feeling a little weird, but we'll go ahead and subtract 40x from both sides, and we notice that the variable is going to drop out entirely. And we have the statement 128 is greater than 126. Well, duh. 128 is greater than 126. This is a true statement. And you may recall whenever we have a true statement, the answer is going to turn out to be, which we can represent using this Blackboard bold R. Interval notation for all real numbers is negative infinity, comma, infinity. And set notation would be the set of x, because that's the variable we were looking at, such that x, we can say, is a real number, and close that up, but that's not how I'd like to do it. I'd like to say x such that x is in the real numbers set. Close the barn door there, and this little e looking thing means it's an element of or is in the set. Now I'd like to consider this inequality that we started out with. And what I want to focus on is this greater than symbol right here. Now I've rewritten the original inequality, and if that greater than had instead been a less than, then when I did all of my work, I would have ended up with 128 is less than 126. Well, that's a false statement. Whenever we're solving an equation or an inequality, the variable drops out and we have a false statement, our answer is going to be no solution, which you can also express using the empty set. Interval notation doesn't so much apply in this case, and in fact, the empty set is all you would have to write to indicate this. Oh my gosh, what a mess. Do you remember the blue star where I mentioned we had possibility of an alternate ending? Well, let's go back through what we looked at. We started with an inequality, and we had collected like terms and stuff, and then we subtracted 18x from both sides, and that gave us a negative coefficient. Well, let's see how we could have done that a different way. I'm going to clean some of this up here. Okay, so in this previous example, we had already distributed to clear the parentheses. We had collected some like terms, and at this step we subtracted 18x and ended up with that negative 3, right? Okay, so instead of subtracting 18x from both sides, we're going to instead subtract 15x from both sides. And what this will do is it'll make it so that we have a positive coefficient on our variable. 27 is less than or equal to 3x plus 21. Now I'm going to subtract 21 from both sides and get 6 is less than or equal to 3x. You'll notice that we're keeping our variable term positive, and when we do that, we end up dividing by a positive 3. Now, when I scroll down here, there's going to be another mess down there, but it's what we already saw before. And here I have, when I perform the division, 2 is less than or equal to x. Now, as we've seen before, I want to flip this around and put the x first, and so here I have the inequality symbol pointing at the 2. It's still pointing at the 2, and this is exactly what we had already. I just wanted to show you what happens when we don't make the variable negative. We don't have to flip the inequality symbol.